Alright, so we're going to take a look at finding volume with known cross sections. Alright, so far we have dealt with circles and cylinders, but in this section we're going to look at squares, triangles, etc. So far we've dealt with circles and cylinders, but in this section we'll look at squares, triangles, etc. instead. But the concept remains the same. The concept remains the same. So example 1, find the volume of the solid if the base is bounded by y equals x squared and y equals 4, and the cross sections are parallel to the x-axis. And the cross sections parallel to the x-axis are... Alright, so we're going to use this example and we're going to do 3 different questions on this one example. So let's say for the first one that they're squares. Alright, so first thing you do is you draw a picture. The second thing you do is you ask yourself, is it in terms of x or y? If it's in terms of dx, which is x, the cross sections are perpendicular to the x-axis, meaning they meet the x-axis at a 90-degree angle. So if it's dx, it's perpendicular to the x-axis. If it is dy, which means it has to deal with y, the cross sections are perpendicular to the y-axis. The listening check, circle 3. Number 3, once you've done that, write the functions in terms of x and y, or in other words in dx and dy. And then number 4, remember that the total area is the area of the top minus the area of the bottom, which had to deal with dx, and you can go back to finding area vertical and horizontal to see that. And then the total area, which is the area of the right minus the area of the left, has to deal with dy. Then finally, find the area of the cross section and the integral of the area to find the volume. Listening check, color the whole of step 5. Color, find the area of the cross section and integral to find the volume. Okay, so let's take a look at this example. So first thing you have to do is you have to draw it. So that's what the curve of y equals x squared looks like. Then y equals 4, you got the y-axis at 4, horizontal line. Alright, so that's the space that's bounded. Now, the word says parallel, but these are perpendicular. Well, parallel to the x-axis is the same thing as perpendicular to the y-axis, okay? So make sure you understand that. Parallel to the x-axis, same thing as perpendicular to the y-axis. I'm going to try and draw this in 3D so you can see what's happening. So I'm just going to slant it a little bit. So this is what my bounding is, my x squared and y equals 4. And what it's saying is that you need to draw squares that are parallel to the x-axis. So this is what it's going to look like. So the cross section bounded by this area, and these are squares. Okay, those look like rectangles, but I'm trying to do squares. Alright, so that's pretty much what they're saying. So they're saying find the volume of these infinitely many squares, which basically are bounded by this area. So really I'm trying to find the area of a square, which is the base times the height. Once I find that, I take the integral of that, and then that's going to give me the volume. So the area of a square is base times height. And again, something to remember, for a square, the base and the height are equal because all the sides are equal. So really what I'm saying is the area is base squared or height squared, whichever one, because it's the same thing. Alright, is in terms of x and y? Well, it's perpendicular to the y-axis, so then it is in terms of dy. Alright, so let's take a look at... Everything basically has to be in terms of y. The integral, the area, all of that. But you can see that the functions in terms of x, we're going to rewrite that in terms of y. So x is equal to the square root of plus or minus root y. Alright, so now everything is in y. But let's talk about the base. So that's the base of one of these squares right here. Alright, so let's talk about how would we find that distance there. Well, that distance is from 0 to the curve, which is plus or minus radical y. So that whole distance would be 2 radical y, because each piece is radical y. So radical y plus radical y. The other way you could do this is you could do radical y minus negative radical y, which will become 2 radical y. If the base is 2 radical y, then the height is also 2 radical y. So the area is base times height, or one of them squared, which is 2 radical y squared. Because we're doing right minus left, And again, I just looked at the distances versus subtracting. I really should have subtracted, but that's fine. And then find the volume by taking the integral of the area. So the volume is the integral from, remember it's in terms of y, so your things have to be in terms of y. So it goes from 0 to 4. And then the area in terms of y dy. And then you just evaluate it. And that's really what it is for squares. I'm not going to actually go into evaluating, we just need to do it. Now we're going to do the exact same question, still parallel to the x-axis, for semicircles with the diameter across the base. This is a listening check. Color in v equals the integral from 0 to 4 of 2 radical y squared dy. Okay, so the distance of the base, so the diameter is exactly the same as it was for the square, so nothing's changing there. So that distance is the base of the semicircle. So you can call that 2 radical y, or you can call the radius radical y. Again, in this shape, it's not going to be squares, but now semicircles, so it would have a round thing. So 2 radical y, or you can call the radius of each thing radical y, because each half is radical y, basically. Alright, so now let's talk about the area of a semicircle. Well, I know the area of a circle, right? What's the area of a circle? Pi r squared. So the area of a semicircle is a half of a circle, so obviously it's a half of the area of a circle, which is a half pi r squared. So now it's already in terms of y, so what's the radius squared? And so it's 1/2 pi y. And now you're going to take the integral, and again the integral is still the same thing from 0 to 4 because that's the area that's bounded, still in the y direction because we're still doing perpendicular, of the area of the semicircle, which is a 1/2 pi y dy. Okay, so now we're going to take a look at one more using the same exact example. Let's say instead we're given isosceles right triangles with the hypotenuse as the base. Isosceles right triangles with the hypotenuse as the base. The listening check, underline isosceles right triangles. So again, the base is still the same thing, 2 radical y, hasn't changed. And then we're going to have, it's a 90-degree triangle, and isosceles means that 2 sides are the same and the hypotenuse is the base. So now instead of it being squares here, these are triangles, and I'm not going to draw that. Alright, so what do I know about triangles? Area of a triangle is a half times the base times the height, right? So the base of this is again 2 radical y, and I don't know the height. I know each of these pieces is going to be radical y, so I know that the area of this is going to be a half, and the base is 2 radical y, and I basically have to figure out what this height is. Okay, so let's see. What I'm going to do is I'm going to split this triangle in half. So I'm going to make another right-hand triangle with radical y, the height, and I'm trying to see if I'm going to be able to figure out what this height is. Let me label this other side z, which is now the new hypotenuse. And I know a squared plus b squared equals c squared. So h squared plus radical y squared is equal to the hypotenuse squared, which I'm going to name z, so z squared. So that's going to simplify to h squared plus y equals z squared. Subtract y to both sides, you're going to get h squared equals z squared minus y, take the square root, and that's what you're going to get. So now that's in terms of h, but there's a z in there, so I need to get rid of that z. So what I'm going to do is I'm going to do, again, a squared plus b squared equals c squared, and I'm going to label, because those are my z's, now do it off the big triangle. So z squared plus z squared equals the hypotenuse squared, which is 2 radical y squared. Simplify that, divide by 2, and I'm going to get z squared equals 2y, take the square root. So I get z equals radical 2y, and I'm just going to put in radical 2y where I see z, and it's supposed to be squared, so it's just going to be 2y minus y, which is radical y. So that's my height. So half base times height, that's my height. So those 2's cancel, and then radical y times radical y is just y. So the area of this triangle is just y. So now we take the volume. Again, it's still the same thing going from 0 to 4. Because I didn't change the question, I just changed the cross-section of the area. And that's it. Alright, let me change the entire question just to make sure we're okay. Find the volume of a solid whose base is a circle with a radius of 4. Find the volume of a solid's base is a circle with a radius of 4. And each cross-section is perpendicular to the x-axis, and it is an equilateral triangle. and each cross-section is perpendicular to the x-axis and is an equilateral triangle. Let's name check color in example 2. Alright, so again it is a circle. Okay, so we have a circle with a radius of 4, so it goes just like that. The radius is 4, so obviously the other side has to be -4. And the cross section of these are equilateral triangles. So it's perpendicular to the x-axis, so it has to meet the x-axis at a 90-degree angle, right? Perpendicular to the x-axis. So what does an equilateral triangle look like? Well, let's do the 3D version, and I'm not going to be very good at this one, but I'm going to try and make triangles perpendicular to the x-axis. And I don't know if you're going to really be able to see what you need to see of this picture, but that's okay. I mean, you get the idea. You start off with a circle and you're making equilateral triangles, basically, an infinitely number of equilateral triangles. It's kind of like mountains off a page. Alright, so is it in terms of x or y? Well, it's perpendicular to the x-axis, so therefore then it has to be in terms of x. So instead of it being in terms of y in this one, it's actually in terms of x. So everything needs to be dx. So here's my equilateral triangle. What does an equilateral triangle mean? All the sides are the same. So instead of labeling them all different variables, I'm going to label them all the same variables. And I still need a half base times height, so I need to figure out what the height is. So first, let me find the equation of the circle. We know the equation of a circle is x squared plus y squared equals the radius squared, which is x squared plus y squared equals the radius, which is 4 squared, which is 16. Alright, so that's the equation that we're working with in this circle. To figure out, because we need all of this in terms of x, I'm going to solve for y. So I'm going to say y squared equals 16 minus x squared, take the square root of both sides, and now that's it in terms of x. So it goes from -y to +y, and the base of it is going to be basically twice that, because it's going from not just 0 to y, but from both of it. So it's twice what y is, because there are two of them. So the distance from -y to 0, then from 0 to y, it's going to be twice the distance from 0 to y. Alright, so to my equilateral triangle, let me label all of them B. So that's base. Let's call all of them base because it's an equilateral triangle. Area is a half base times height. So I know that if I split the triangle in two, I'm going to have a half triangle that looks like this, and it's going to make a 90-degree angle. The base is not going to be a half of the base because I split it in half, and the height is still the height, and the hypotenuse is still the base. So now I can use a squared plus b squared equals c squared and plug them in. So a half b squared plus h squared equals b squared. And then go ahead and simplify that. I'm going to get a quarter b squared plus h squared equals b squared. Simplify for h, solve for h, and I have b squared minus a quarter, which is going to give me 3/4 b squared. And then take the square root of that, so it's going to be the square root of 3b squared over 4. And I can separate top and bottom, so I can take the square root of 3b squared over the square root of 4, simplify that, and I'm going to get h is equal to the square root of 3b over 2. Now I'm going to put this in here. So area is a half base times the height, and that's the height. And I can simplify this to give me radical 3 over 4b squared. Well, b squared, remember, is 2 radical 16 minus x squared. So just plugging that in, this is now what my new equation. And look, it's all in terms of x. So now I can find my volume in terms of x. That was squared. It's supposed to be b squared. I forgot to put that in there. So it simplifies basically to radical 3 parentheses 16 minus x squared close parentheses. To find the area in terms of x, we need to go from -4 to +4, because remember the radius was 4, right? So if it's from 0 to 4, then the other side is -4 to 0. So -4 to 4 of the area in terms of dx. And that's pretty much all there is to it. So you really just need to remember, if it's in terms of x, it's perpendicular to the x-axis. If it's in terms of y, it's perpendicular to the y.